Hey everyone, and welcome to The Explainer. Today, we are tackling a major hurdle that trips up so many qualitative researchers, and that is NVivo's coding comparison query. Honestly, if you've ever found yourself just staring at a massive wall of reliability statistics, wondering what they actually mean for your research, well, you're in exactly the right place. We are going to completely demystify these numbers, using some fantastic insights from Dr. Philip Adu, to make sure you know exactly how to measure and confidently report your coding consistency. Okay, let's dive into this. Here is our roadmap for today. 1. The foundation of consistency. 2. Reading the reliability numbers. 3. Avoiding the agreement trap. 4. Decoding the overlap columns. And 5. Improving your codebook.
Section 1. The foundation of consistency. Before we even think about looking at a percentage point, you have to remember the golden rule. Coders must be totally aligned. If researchers are using different codebooks or even just vague instructions, it's literally like comparing apples to oranges. NVivo will happily crunch the numbers for you, sure, but the statistics it spits out, completely misleading. The real foundation of a reliable, interpretable comparison is when both coders are using the exact same codebook.
So the crucial point here is that inter-rater reliability is really just answering one specific question. If two coders use the same coding rules, do they apply the same codes to the same parts of the data? And to make absolutely sure that happens, your shared codebook has to include a few essential elements. We're talking identical code names, crystal clear code definitions, strict inclusion and exclusion criteria, and concrete examples of how to apply them. Without these shared elements acting as your anchor, the software's comparison doesn't really mean a thing.
Moving right along to Section 2, reading the reliability numbers.
Enter the star of the show, Cohen's Kappa. This is absolutely the most important statistic in your report, and here's why. It actually measures agreement beyond chance. It mathematically corrects for the probability that you and another coder just happen to code the exact same sentence randomly. Looking at this scale, it goes all the way from poor, which is 0 or below, up to almost perfect agreement, sitting between 0.81 and 1.0. As a general rule of thumb, you'll want to aim for a kappa of 0.75 or higher to really demonstrate strong qualitative coding. Always check this number first.
Section 3, avoiding the agreement trap.
Okay, let's meet what I like to call the false hero of qualitative analysis. 96% agreement. I mean, wow. If you're a novice researcher, you see this number pop up on your NVivo report, and you are probably thrilled. 96% sounds fantastic, doesn't it? It feels like an automatic A+. But then you look just one column over on that exact same report for the exact same code, and you see this. A Cohen's kappa of 0.00. Yikes, total failure. So why does this happen? How is it even mathematically possible for two researchers to agree 96% of the time, yet have a kappa score of 0, which basically means no meaningful agreement whatsoever? Let's move to Section 4 and see how this builds. Decoding the overlap columns. To solve this mathematical mystery, we have to peel back the curtain and look at the 4 coding overlap columns. NVivo looks at every single text segment and asks one simple thing. Did the coders apply the code? The A and B column is our positive agreement. You both coded it. But the not A and not B column is our negative agreement, meaning neither coder applied it. Remember that 96% agreement trap we just talked about? Well, that usually happens because the vast majority of the transcript was left uncoded. Both coders simply agreed to leave it blank. But when it came to the actual text they did code, they completely disagreed, and that shows up in the A not B and B not A columns. High agreement percentage often just means a lot of blank space. It definitely does not equal high reliability. And watch out, because there's actually a second trap. A perfect kappa does not automatically mean excellent coding. Take this scenario, for example. Your kappa is 1.000, agreement is 100%, but then look at the overlap columns. A and B is 0%, while not A and not B is 100%. All this really means is that both coders perfectly agreed that the code never appeared in the text at all. Literally nothing was coded. To boil the mechanics down simply, disagreement columns drag your kappa score down, while agreement columns push it up. True, meaningful reliability requires strong overlap in the A and B column. That means both coders actually found and applied the code to the exact same text. Which brings us to Section 5, improving your codebook. And this brilliantly illustrates the fix. It's an alternative best practice for ensuring reliability right from the jump, called the collaborative coding strategy. Basically, don't just dive headfirst into the deep end. First, you build or agree on your codebook. Then, both coders independently code the exact same small sample of data. After that, you compare your differences, revise your codebook, and only then do you continue coding the rest of the data with that much improved consistency.
When you inevitably hit a bump, like a low Kappa score or disagreements popping up in those A not B or B not A columns, here's your practical game plan. Step 1. Review the code definition together. Step 2. Compare each coder's excerpts side by side so you can see exactly what was captured. Step 3. Discuss and clarify the boundaries of the code. Step 4. Refine the codebook with these new insights, maybe add some concrete examples. And finally, Step 5. Repeat the whole process by recoding a fresh sample and checking your stats again.
To make this totally foolproof, here's a mental checklist you should run through every single time you open an NVivo reliability report. Just ask yourself, 1. Is the Kappa acceptable for my study? 2. Did both coders actually apply the code? 3. Is the agreement mostly just uncoded text? 4. Where exactly are the disagreements happening? And 5. Does the codebook need some refinement? Now, what's really interesting about this slide is the core truth it highlights. Reliable coding comes from clear definitions, not from software. NVivo only measures consistency, guys. It's essentially just a calculator. It is your rigorously developed human-made codebook that ultimately determines if that consistency is actually meaningful to your research. So, I'll leave you with this final thought to chew on. Are you letting software dictate your reliability, or is your codebook truly doing the heavy lifting? Don't let those sky-high agreement percentages lull you into a false sense of security. Go audit those codebooks, double-check your Kappa scores, and make absolutely sure your definitions are rock solid. Thanks so much for joining me on this explainer, and happy coding.